Hello viewers wherever you are, and welcome to another video of chemistry on Fauzan Haroon channel, the channel of choice. Please do subscribe to the channel if this is your first time of joining us on this chemistry lesson. We are going to look at the next subtopic in the next subtopic is molar mass. Molar mass. This is our next subtopic, molar mass. So all these are subtopics under the general topic, the mole and amount of substance. So we are still on it. The next subtopic is the molar mass. That is what we are going to look at now. What is the molar mass? The molar mass is simply the mass of 1 mole of a substance. Molar mass is simply the mass of 1 mole of a substance. Mass of 1 mole of a substance. That's the molar mass. I wouldn't want to waste time and write. Most of you are aware, at least if you are doing chemistry or a science student for that matter, that definition should be basic. Should be basic. And if anything at all, I've said it, so if you want to write it, you can write it. The mass of 1 mole of a substance is the molar mass. Its unit is the grams per mole. Its unit is grams per mole. That's the unit of molar mass. Its unit is gram per mole. That's the unit for molar mass. And then there is also a relationship that we have to take note of. 1 mole of 1 mole, mass of 1 mole of a substance. Mass of 1 mole of a substance contains mass of 1 mole of a substance. Mass of 1 mole of substance contains 6.02 times 10 to the exponent 23 entities. In effect, it contains 6.02 times 10 to the exponent 23 mass of a substance, contains Avogadro's. 1 mole contains Avogadro's. 1 mole of any substance contains Avogadro's. 1 mole contains Avogadro's constant. Hence, if 1 mole contains Avogadro's constant, mass of 1 mole of a substance also contains 6.02 times 10 to the exponent 23 entities. Remember in my previous subtopic, I said the entities could be what? The entities could be atoms, ions, electrons, ions, electrons, and the likes. So those could be the entities we are talking about here. Numerically, molar mass is equal to relative atomic mass. Numerically, in terms of number, molar mass, I choose to represent it with capital M, is equals to relative molecular mass. In numerical terms, they are equal. And so meaning if in numerical terms they are equal, if you have the relative molecular mass of H2O, water is 18. The relative molecular mass of H2O is 18. The molar mass of H2O will be what? 18 grams per mole. Remember, its unit is gram per mole, so it's the molar mass of water H2O will be what? 18 grams per mole. So if MR of water, relative molecular mass of water is 18, automatically implies Molar mass, I choose to represent it with capital M of water, is what? 18 grams per mole. So that is the implication. Because we say the molar mass has units and the relative molecular mass has no unit. It is representation of one factor with respect to the other, meaning the numerator divided by the denominator. Hence, the unit will cancel out. There wouldn't be unit in the comparison. If this is your first time on the show, please do well to subscribe to the channel, please. It's very important. So that when there are topics and classes on the show, you are going to be alerted accordingly. So we are going to take some questions to understand in details the perspectives of what I'm explaining here. And I'm going to take some questions here to understand the perspective. Give the viewers more detail of what we mean by molar mass. We're going to take a question. The first question is, calculate the molar mass. Question, calculate the molar mass of 0.25 mole of carbon 4 oxide, which has a mass of 11 grams. So that is the question, which has a mass of 11 grams. That is what we are going to attempt to solve. Calculate the molar mass of 0.25 mole of carbon 4 oxide, which has a mass of 11 grams. So solution. We are going to solve it. Solution. Those of you in chemistry are familiar with this formula. Amount of substance is equals to mass over molar mass. So if amount of substance is equals to mass over molar mass, what you do is to make the molar mass the subject. This molar mass, you have to make it the subject. That's equation 1. And then equation 2, you multiply both sides by m. We have, that is mass. I don't want to do it. Let me go straight forward and do it. Equation 2, this one goes here and then this one comes here, meaning you multiply 2 by m over n. So multiply 1 times m over n. So we do m over n times n is equals to m over m times m over n. So when you do this, this will go off. This will also go off. So this is equation 2. So m is equals to m over n. M over n. So the m, small m is the mass, and this is amount of substance, and this is the molar mass, where n small is amount of substance. Those of you in chemistry know, but let me do it. Small m is equals to mass, and then capital M is equals to what? Molar mass. That is what we are finding. Capital M is the molar mass. That is what we are finding. And so when you have this scenario like this, and we have mass which is 11 and then the amount of substance, which is 0.25 mole. We just do change of subject. M is equals to mass, which is what, 11 grams, and then N amount is equal to 0.25 mole. So you do it 11 over 0.25, and the answer will be, I think, 44 grams per moles. So 44 grams per moles will give you the answer. So this is the answer. In equational form, we are going to do an alternative method to also solve the same equation. We are going to solve the same equation with different method again. So this is one aspect. Let me give you some 10 seconds to go through it effectively. Let me give you some 10 seconds before I delete and give you the alternative solution again. If this is your first time of joining us, please do subscribe to the channel. Yeah. So, give you some few seconds to also go through. Please share the program for students to also benefit from these classes. Share the program, the classes for other students to also benefit from these classes. Okay. So that is what we are talking about here. So let me clean it and give you the alternative solution to this same question. Okay, let's do the alternative method. Okay, alternatively, meaning you can use the other, so the solution that I've just given you, or this one. If 0.25 mole CO2, the carbon 4 oxide is the CO2, contains 11 grams. If 0.25 mole contain 11 grams, 1 mole CO2 will contain what? 1 over 0.25 times 11 grams, which will be what? 44 grams of mass. So if it contains 44 grams of mass, its molar mass of CO2 is 44 grams per mole, 44 grams in 1 mole. So this is the alternative. In the equation, if 0.25 mole contains 11 grams of this, of CO2, 11 grams CO2, 1 mole CO2 will contain how many grams in terms of mass? 44 grams. And so the molar mass of these 44 grams is 44 grams per mole. So this is an alternative solution to the same question. We are going to look at another question. Let me give you some few seconds to also go through. It before I delete it accordingly. We are treating molar mass today. Okay, so let's take the next question. Take the next question. Let's take another question. The next question, calculate the amount of oxygen. Calculate the amount of oxygen in moles of oxygen gas. Remember, atomic mass of oxygen is 60. Solution. We are going to calculate the amount of oxygen, moles of oxygen gas. So this, let's do it straightforward with the formula. I wouldn't want us to waste so much time. Amount of oxygen is equals to mass of oxygen amount of oxygen gas, mass of oxygen gas over molar mass of oxygen gas. So calculate the amount of oxygen in moles of 8 grams, 8 grams of oxygen gas, in moles of 8 grams of oxygen gas. So this is the amount that we are going to calculate. The mass in the question has been given to us as 8 grams. And then we have to calculate the molar mass. And remember, we have the atomic mass of oxygen to be 16. And atomic masses are used to calculate molar masses. Those of you heard it in my previous lessons. And if you have atomic mass, you can get the molar mass. So with the molar mass for oxygen gas is equals to, because we have 2 atoms of oxygen in oxygen gas, we have 16 plus 16, which is equals to 32 grams per moles. Or the molar mass of oxygen is equals to what? Because we have twice of these 2 atoms times each component which contains 16 grams. Hence we have still 32 grams per moles. Either way, whatever procedure you do it, you will still arrive at the same answer. It contains 2 atoms. And then this one contains 2 atoms, but each atom has 16 grams. So 16 grams per mole. 16 grams per mole, the atomic mass in 1 mole. And this one, twice of that 16 grams, 2 times that. So hence the amount of oxygen gas will be what? The mass 8/32, which is equals to what? I think 0.25 moles oxygen gas. 0.25 moles oxygen gas. So that is the answer. 0.25 mole oxygen gas. So this is straightforward. We can use the other alternative method too. Let me clean this one and give you the alternative method. The alternative solution. This is the formula solution. We just quote the formula and substitute the values. I think this one is straightforward. You do it by defining the values. N, small m for mass, capital M for molar mass, and then small n for amount of substance. Just make sure you define them, please. If you don't just put them just for quoting sake, make sure you define them. So the alternative method is if 32, remember when you calculate the molar mass, you get 32 grams per mole. So the 32 molar mass, 32 grams per moles means if 32 grams contains of CO2, of oxygen gas contains 1 mole, 8 grams oxygen gas will contain what? 8 over 32 will contain how many number of moles? Will contain what? 0.25 mole. Remember, these grams will cancel grams. So this is the alternative method. You will still get the same answer for that matter. You will still get the same answer for that matter. So still get the same answer for that matter. The same answer for that matter. So let's take another question. We have to take another question. Let's take another question. Let's take another question. The question says calculate the number of molecules. Calculate the number of molecules in 1.7 grams 1.7 grams of ammonia solution. Calculate the number of molecules, meaning number of molecules of ammonia. The formula is quoted as this: is equals to amount times the Avogadro's, and then we are given the atomic masses of nitrogen 14 and then hydrogen to be 1 here. The relative atomic masses. So we need to, for us to calculate the number of particles, we need the amount, and then the Avogadro's, as you know, is L is equals 6.02 times 10 to the minus 23 molecules or entities. You see, so we need to first find the amount of substance. And amount of substance, capital N is equals to number of particles, number of molecules. That's what we are finding. N is equals to amount of substance, small n, amount of substance. And then N is equals to what? Avogadro's constant. I said anytime you are giving question, you have to define them when you quote the formula. Don't just quote formula. So we are now going to find the N, this small n amount. And N we know is equals to mass over molar mass. And then mass over molar mass. i.e. M over capital N. So N is equals to, the mass has been given in the equation, which is what? Mass is equals to 1.7 grams. But the molar mass, we need to calculate it because we have the atomic masses here. We can calculate the molar mass for ammonia. And ammonia is equals to molar mass of NH3. That's the formula for ammonia, NH3. So it's equals to 14. We have one hydrogen atom which contains 14 plus 3 times nitrogen atom which contains 1. So 3 times 1. Hence 14 plus 3 is equal to 17 grams per mole. 17 grams per mole, that's the molar mass of ammonia. After finding the molar mass of ammonia, let's use it to calculate the amount of substance. And the amount of substance, as you are aware, is equal to mass over molar mass. So we have amount which is equal to mass which is equal to 1.7 over 17 molar mass, which will give us what? The amount will give us 0.1 mole, 0.1 mole. And then if we know the amount 0.1 mole, we can calculate the Avogadro's constant. Hence the number, we can calculate, the number of particles, because we also know the Avogadro's constant. Hence N is equal to 0.1 times 6.02 times 10 to the exponent 23 ammonia molecules, NH3 molecules. So hence the answer will be 0.1 times that, which is equal to what? Which will be equals to, let me see from the calculator. I think it's 0.602, but let me be sure. 0.602, but let me be sure. So 6.02 times 0.1. So when you are writing it in so it's 0.0602 times 10 to the 23, or 6.02 times 10 to the exponent 22 ammonia molecules. Those of you who know, because this 0.1 is the same as 1 over 10. 1 divided by 10, and hence 1 divided by 10 will cancel 1 0 here. Remember, we have 23 zeros here. Zeros 1 times 10 times 10 times 10 up to 23 times. So 1 over 10 here will cancel to a 10, at 10 here. And we have 10 to the exponent 22 by maintaining this 6.02, and we have, that's calculator. There is no need for me to explain, that's calculator. So you check from your calculator. So that is another example we've calculated for you. So I think, let me end this video by giving you one assignment before I end the video. This is straightforward. So I think, thank you very much for joining us on this edition of Molar Mass. I think I will have some more calculations for you in the subsequent videos that I will get. I will have some calculations for you in my subsequent videos. Thank you very much for joining us on the show, and hope to meet you in the next video. Cheers.